No matter how green, how furry, how small, how big, or how weird, all known life forms are based on the chemistry of one element, carbon. But why carbon? And if we look out to the stars, could there be a fundamentally different kind of life out there? Questions like these are really hard to answer because we only know life on one planet, ours. Life here on Earth is fundamentally chemical. DNA and proteins are both super long, basically infinitely variable polymers based on carbon. Fats and sugars are based on carbon. Most molecules cells use to signal each other are based on carbon. We don't know of a single life form that doesn't use carbon as the basic scaffolding of its own existence. Of course, life needs more than just carbon. A lump of pure carbon, whether graphite or coal or diamond, is not alive. But carbon does seem to occupy a special place among the elements, at least here on Earth, and probably on other Earth-like planets as well. Let's take a look at some of the reasons why. First of all, carbon is fairly promiscuous, meaning it can form bonds with a wide variety of elements. In this drug, carbon is married to other carbons, oxygen, chlorine, nitrogen, sulfur, and hydrogen. Secondly, carbon can bond a bunch of different ways. It can form incredibly stable bonds with some elements like hydrogen, and it can form less stable, more reactive bonds with others like oxygen. Carbon can form tetrahedral, aka diamond-like shapes, it can form flat rings, and it can even form molecules that look like those rickety beach lounge chairs you constantly fell off in the 90s. And with help from other elements like hydrogen, nitrogen, oxygen, phosphorus, and sulfur, carbon can form the backbone and side chains for the incredibly long polymers that are key to life here on Earth. But it's not inconceivable that, somewhere in the universe, elements other than carbon could be the building blocks for life. Silicon, right below carbon on the periodic table, and therefore with some similar chemical properties, has popped up as a potential alternative. Silicon shares a lot of similarities with carbon, including its ability to bond to oxygen and to create long polymers. But it has some major setbacks. First, silicon struggles to create multiple bonds because of its size, and the bonds it does make are much less stable. But what really puts the nail in the coffin is that when oxidized, silicon creates a solid, silicon dioxide, otherwise known as sand. Whereas when carbon is oxidized, it creates a gas, which is easy for plants to access and make sugar from. While silicon has stoked the imagination of science fiction writers, the scientific community has yet to find enough evidence to suggest the potential of silicon-based life. Some life can already use silicon though, like in these beautiful shells, and scientists are evolving organisms that use it in other ways too. Using a technique called directed evolution, scientists generated mutations in an enzyme called cytochrome C in bacteria from Icelandic hot springs. Over several generations, the mutated bacteria were able to produce 20 different compounds with silicon-carbon bonds. Finding alien life forms outside of our solar system is hard, and not just because it would take forever to get to any Earth-like exoplanets. In theory, astrochemists can measure different wavelengths of light traveling through an exoplanet's atmosphere to get a sense of what chemicals that atmosphere is made of. If we see a lot of small molecules floating around, like oxygen or methane, that could mean that there's life down on the surface. But trying to measure the light signature from a planet trillions of kilometers away when it's sitting right next to or right in front of a star as bright as our own sun is a chemical trick we haven't quite figured out yet. Inside our solar system, we've got other options. There are places that used to have or still have liquid water, and that's a good first step since all life we know uses liquid water. Scientists speculate that non-water life might be out there too. Titan has seas of liquid methane and ethane, and it could be that life has figured out how to chill on Saturn's largest moon. Get it? Chill? Because the average surface temperature of Titan is negative 180 degrees Celsius, so it would have to be chill. There, I did it again. What do you think, folks? Can you imagine silicon-based life on other planets? Any interesting takes on new life? Let's get a discussion going down in the comments, and we'll see you again soon.